Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. We continue looking at multi-threading. In our previous videos we've seen how you can create threads, how you can make them do things, how you can cause race conditions, and how you can deal with them. In this video I want to look at two other low-level calls that you can use for trying to keep threads working together. And these are wait and notifyAll. There's also a notify method, but it's strongly discouraged. The usage of it is strongly discouraged, so we're not really going to talk about it. The basic idea of wait is that wait causes a thread to stop running. It goes to sleep for an indefinite period of time. And that indefinite period of time ends when some other thread notifies it to wake up. And so this allows you to have certain threads stop doing things and then not restart until some other thread tells them that they should do so. As you can probably see from that description, one of the challenges here is if no other thread tells you to do something, then you're deadlocked. Okay? And so you do have to be very careful with this. And once again, as with the other videos, we're talking here about very low-level calls. This is, in some ways, how everything that does multi-threading is written. That doesn't mean that you want to be doing this all the time. We'll talk about higher level approaches to it. But you still need to understand the low level for at least two main reasons. One is just for a basic understanding of what's going on. Another reason, and perhaps the more important one, is that you need to understand these things so that if you ever find that you need to do something and there isn't a library feature that does what you want, you will have to use these things. Okay, so it's good to have this foundational knowledge so that you're not trapped if you find that the libraries don't include the functionality that you want. So I took the code from last time and I pulled it off into a separate method, and we're going to write another method this time. I'll call it simple collisions. This is going to pull from the research that I do. It's we're not going to write a full-on particle collision code, but it's going to be somewhat like that. So the idea here is that I want to have a case class that represents a particle, and every particle needs a position with an x and a y. It needs a velocity with a Vx and a Vy, and it needs a radius. Okay. We might wind up putting some extra methods in here a little later. And what I want to do is I'm going to create a whole bunch of particles, and they're going to have their velocities, and they're going to run around. And I want to have this go through, find particles that are overlapping, and then do something with them. Now, where the wait and the notify come in and the multi-threading comes in is, first off, I want to do this so that the work is broken across multiple threads. Okay. Second of all, I want to have it so that we need to have it so that, for example, you find all of the particles that are overlapping before you move on to your next step. There are reasons why that actually has to happen in a real simulation code, and what we're going to write here might not necessarily require it, but it helps us to show how we can use the wait and the notify. And so what I want to do is, first I want to make some particles. I'll make an array that has 10,000 particles. And the particles will be located, I'm going to go with, let's do math.random minus 0.5, comma, math.random minus 0.5. The reason for doing it that way is random minus 0.5. Sure, I'm going to wind up doing that for all of my values. Oops. Comma, math.random minus 0.5, except for the radius. The radius is going to be there. And what is this? Okay, now it's happy. I want these particles to be split across the so that they're not all in the top quadrant, and I'm going to break this work across 4 threads, and those 4 threads will cover the first, second, third, and fourth quadrants respectively. So how about we put a method up here so that every particle can tell us what quadrant it's in, and this is going to be equal to, if, let's actually put some parentheses, if x is greater than, if x is less than 0, we'll go with greater than 0, 1, else 0, plus if y is greater than 0, 2, else 0. And you can think about that a little bit, how that works. If you are negative in both values, you will come out in quadrant 0. If you're positive in x but you're negative in y, you'll be in quadrant 1. If you're positive in y but you're negative in x, you come out in quadrant 2, and if you're positive in both, you come out in quadrant 3. It's just a nice, simple way of giving us a one-to-one function for particle positions to the 4 quadrants. And so I want to take these particles and I want to split them up across the quadrants. And let's do a best way to do this would be, sure, groups equals particles dot grouped by, and the function that I want is underscore dot quadrant. Now groups is not actually, it's not a simple array, it's a map. Now it turns out quadrant only gives us 0 to 3, and we know that, so each element of the map will be an array of all the things that gave us back that quadrant. And then what I want to do here is I'm going to start off 4 threads, and I want to have them running. So I want to run through my 4 quadrants, and I'm going to make my 4 threads, and each one of these is going to have the code so that, let's just start typing some of the basics here. We'll make a new runnable. I'm missing an E. So we make a new thread, we make a new runnable inside of that thread. And what happens inside of the run method in here is that I want to first, so first I'm going to actually have, I don't know, how many steps do I want this to go? 4 step in 1 to 10. We could change that later. So each one of these is going to go through 10 steps, and what's going to happen in each step is first you check for collisions, okay, or for overlaps. After you've found overlaps, then we need to handle them. And the thing is, these are in separate things because I actually want them separated by time. Handle overlaps, do whatever it is that I was supposed to do with them. And then advance the particles. And all of these 3 need to happen separately. And I want to put in synchronization points in between them. Now, the way that we're writing this code, maybe I don't have to put in synchronization points, but in a real simulation there would be reasons why I do need to synchronize every so often, so that, for example, I can't move on to one step until all 4 threads have finished with the previous one. So in fact, I could just def find overlaps is going to take, we'll call it parts as an array of particle, and it's going to return to me a list of 2 integers, which are the indices of 2 particles that are overlapping. Okay, so I can stub that out so it returns nil. And what's supposed to happen here is actually, okay, let's val parts equals groups. Actually, because they're, I want to, well, groups sub I. Okay. Find overlap of parts val overlap indices equals, let's find overlaps, it should be plural, of the parts. Then I will handle the overlaps. Also needs a to do. This one, however, actually, I think my life will be a little bit easier if I make this so that these are all, I'm going to make this a highly mutable inner class. It will fit better with the style of code that I'm going to write. However, particles will not change size. Handle overlaps takes all the particles, and then the overlaps, which is a list of int, and it is actually not supposed to return anything. It is supposed to alter the particles because it's an array. I guess I could have. I can go back to the case class and it doesn't matter either way. Oh well, it does, and that I don't have to do a new. It will alter my coding a little bit, but they're arrays, so I can make copies of things and store it in there. Okay, so this is supposed to change all of the velocities of the particles, and then def advanced particles just takes the particles and once again this one mutates them. So I'm perfectly happy with that. It's worth putting in here, so val dt equals 0.01. This would be a time step for how far you would move, and at least the advanced particles is fairly easy in that I can do a for loop of I in parts dot indices parts sub I equals parts sub I dot copy with x equal to x to parts sub I dot x plus dt times parts sub I dot vx, and a similar thing for y. Recently upgraded my Scala IDE Eclipse install, and because of the Juno, it's the nightly build. And it's running a fair bit slower now. It's hanging at various points. Hopefully that will be corrected in fairly soon. So the handle overlaps is, well, a call to handle overlaps on parts and overlap indices and the advanced particles. Well, that's what we called it. Advanced particles on parts. Do I have a typo? Advanced particles? Advanced particles. Okay, no, it's happy. Now the thing is, though, that I have this is going to be happening in 4 different threads, and each different thread has its own group of particles. Oh, and then I guess I should exchange particles. We'll come back to that in just a second. And actually, the way I've set this up, I guess I would have a hard time doing that unless I make it, instead of being an array, I make it a buffer. Well, not going to worry. What matters at this point is talking about the waits and notifies. So the way I've written this, in theory, I could have it so I create 4 threads, and then I do the find overlaps in those 4 threads, and then I join them all, and then I create another set of threads, and I join those all, and I create another set of threads, and I join those all, and I would have all that inside of one loop. That would work, but there's significant overhead to creating threads, and that way, that approach really isn't as general as what we can do with wait and notify. So what I want to do here is I want to have a wait, okay, assuming that not everyone has completed. Okay, so let's do no, not a val, a var complete count is 0, okay, and we'll first talk about the logic. So if complete count is less than 4, or sorry, it's less than 3. So when the first one completes, it looks at the complete count and says, oops, not everyone's done, I'm going to wait. So what happens here is that complete count needs to be incremented, and we're going to wait. Okay? And then next up will be a then the next thread will go and it'll check and it'll say, nope, it's not up to 3, and so it increments it to 2, and then it waits. And then the third thread comes through and says, nope, 3 is still less than, or 2 is still less than 3, so it increments it to 3 and it waits. When the fourth thread gets done with finding the overlaps, it hits this line and it says, oh, hey, look, complete count is already 3, and so instead of doing what it had been doing, instead of doing what all the others did, it says, hey, let's notify all. Okay, let's tell you all to wake up here, and then complete count is set to be 0 by that one thread. Okay. So let's see if I can run this. Let's put simple collisions inside of main, because there is an error with this right now. Simple collisions. Oh, yeah. Right now it's worse than an error. Yield threads equals threads dot for each underscore dot start, plural. The error isn't going to occur unless I actually start my threads. And this is a Scala application. And was this the thread that was this the error I was waiting for? Illegal monitor state exception. Yes, that was the one I was waiting for. So, turns out that you can't wait, nor can you notify all, if unless you are synchronized. So what I want to do is I need to be inside of a synchronized block. This code right here does not need to be inside of a synchronized block. I don't want this to be inside of a synchronized block. I want all 4 threads working on this find overlaps at the same time. However, this needs to be inside of a synchronized block. So I am going to synchronize on that. And now if I save that, I can run. Of course, our methods don't really do anything right now. I was in the middle of compiling. Yeah. The IDE has definitely gotten into a weird state. Oh, where's exception in thread? Oops, that was not what I want to do. Illegal monitor state exception, that's the same. So we had 3 of them get this. And wait exists on, that's our, we need to be waiting on the same object that we are synchronized on. If I were to just call wait, then I would be waiting on the runnable that I am embedded in. And there it went, it ran, and of course I don't really have it doing anything in these methods yet. So because this is synchronized, and in fact, and the fact that I don't know if anyone watching this video, it's hopefully as you were watching this, as you were watching me type this out, little warning light should have been going off in your head, because this would be a race condition normally. This is a shared var, it's mutable memory, it's shared by all 4 of my threads, and it would be possible for one of my threads to come in and check and say, oh hey, complete count is less than 3, while another one had already done its check, and then they both wind up incrementing, and then they both go to sleep, and then no one wakes them up. Okay, so imagine if the first thread hits here, it says it's less than 3, everything's fine, it increments and it waits. Next one hits it, everything's fine, increments and it waits. The next 2 hit almost simultaneously. They both look, they both see a value of 2, and then they both increment and they both wait. Okay, well, that would be a problem. So if the second thread coming in decides to, or manages to do the check before the one before it has done an increment, we have a problem here. So that's not what not what I want to do. I need this to be synchronized. Only one thread should be able to come into here at a time. And that way, when you check this value, you know that you're the only one that's looking at this value. You are the only one that's using it. So then you get to increment it. Now you might wonder about this. Well, then if I wait and I'm blocking that object, isn't that a problem? And the answer is no. That when you call wait, when you wait, you wind up releasing your lock on this, and so then other threads can come into it, but now they're safe to do these checks and it won't be a race condition across what you were doing. When that last thread manages to get into this synchronize block and it jumps down to here, it calls notifyAll. All the other threads are notified that they can wake up. That does not mean that they immediately start processing, and in fact, because you're inside of a synchronized block, they can't start processing until this thread leaves the synchronized block. And so then this comes down. The way this is written, I could actually put that there and there again. Of course, this should be one of those things where I just duplicated code several times, and that should make you feel uneasy, in which case if it does, good. Because we'll see that there are things in libraries that will do exactly this functionality right here better for us. But this gives you at least a little bit of an introduction. I'm not going to bother going through and writing what all of these other functions would do, because it really isn't all that significant to us. The main idea is that you can wait and then have a thread wait and then have a notify. Now, it's worth taking 1 second before we finish this to talk about standard ideas for wait. So, and the fact that there is a notify as opposed to notifyAll. NotifyAll will notify every thread that is waiting on this object. It tells them all that it is time to wake up. There is a regular notify method, and it only tells one thread that it's time to wake up. Even if you think you want that, do not do it. Okay? Even if you feel very confident there's only one thread waiting for you, do not use a regular notify. And the reason you should not use a regular notify is because you can't be certain that, for example, someone comes in later, that someone might be you, and you've forgotten that you used a notify and that there was only supposed to be one thread waiting on this object, and you happen to add one more thread that's waiting on the object. Well, now you have a problem, because notify randomly picks which one to wake up, and if it picks the wrong one, you wind up with a deadlock situation. So always use notifyAll. Now in this case, my notifyAll really was supposed to wake up everything. A standard recommendation is that your wait should always go inside of a while check. And so I would have this still finding Boolean. Okay, and this would be set var still finding equals true, and after everyone is done down here, still finding equals false, something along those lines, so that you can selectively tell if you wake up 5 threads and you really only wanted 2 of them to wake up, you would set the Boolean that is being checked so that the 2 that you want the Boolean will be false and they will actually wake up and do what they're supposed to do. The others will wake up, this Boolean will be true, and they'll go right back to sleep. Okay, so it's a general recommendation that you never use notify, that you use notifyAll every time, and that typically your wait statements should be wrapped inside of while loops. So that's a brief introduction to what you can do with wait and notifyAll, and we'll come back and look at some of the higher level libraries that can help prevent you from having to go down to things that are this low level in the next video. That's it for now. See you again soon.